All right, folks, I think we'll start. I have 6:15. Those who, actually it's 6:20. Wow, okay. So let's backtrack a moment. See, our concern here is to be able to understand what is all this for. Right? What are we hoping to accomplish with all of this? Because sometimes it's easy to get sort of overwhelmed by the math. Sometimes it gets very theoretical, and we lose track and we lose sight of the bottom line. Right? We're looking at this whole activity from the perspective of the firm. Right? So what is it that the company is interested in? Whether you're a producer, you're a manufacturer, whether you have a small business, whether you have a sole proprietorship, a mom and pop store. All right. So we're taking the perspective of the company, of the firm. Now, we're very familiar with the demand equation, the demand function. The demand function, in this case, QD equals 8.5 minus 0.05p, the demand function says at various price levels, so if we charge various prices, the demand equation is going to tell us how much our customers will be demanded at these various prices. And that's usually very interesting and very informative for our business. However, there are many occasions where we want to be able to control how much we actually put out there for the customers, how much we put on the shelf, how much we stock, how much we import. So we want to be able to control the queue. Right? And if we, for example, decide we're going to import, let's say, 200 units of a certain item. All right? So we get to control that. Our concern then is that if I bring in 200 of this item, am I going to be able to get all of these sold within a requisite period of time, whether it's a week or a month or whatever it is? Right? And in that case, then it's very important for a company to know, a business to know, well, what kind of price should I be considering charging for these items if I expect to be able to sell all 200 in the time period that I want to sell them? Right. So the business in this case gets to control the output, gets to control the queue, gets to control how much they're stocking on the shelf, and then they decide on a price that they need to charge if they were going to sell that amount. So it's sort of turning everything the other way around and putting the control over the output in the hands of the business. Fine. The business is also very interested, most importantly, is interested in knowing, okay, if I were to bring in these 200 items, how much money I will make when I sell these items if I were to price them the price that I'm thinking. So that's my revenue. My revenue is how much money I'm going to make that's going to hit my cash register if I were to sell these 200 items at the price that I'm thinking of. That's my total revenue. And we're interested, just as interested then, is what is going to be my total cost of bringing in these 200 items and making them available to sell. Because that total cost may not just include the cost of bringing them in, but any fixed cost associated with, for example, I may have, these items may require refrigeration, or some special care. So it's not just the purchase of the item, but making them available to sell. So, based on my 200 items, I want to know what's going to be my total cost of bringing those 200 items in and making them available to sell. So I want to know what price I'm going to charge to sell those 200 items, how much money is going to hit my cash register, my revenue, if I were to sell those 200 items at the price that I'm thinking, what is going to cost me to produce and sell those items, and finally, what will be my ultimate profit from the production and sale of those 200 items. So that's what we're interested in. Then, as a sort of advanced understanding of my business, I want to look at what is called marginal revenue and marginal cost, and in fact, marginal profit. Marginal cost is the easier one to start with. Marginal cost says that I brought in 200 items. All right. So what is my additional cost for bringing in each additional item? All right. Is it the same for each of the items? If that's the case, let's say I bring in 200 items, and the cost to bring in each one of these items to make it available to sell is the same. In that case, my marginal cost for each of these items would be the same. Fine, I can live with that. What about marginal revenue? Marginal revenue, we say, my total revenue, I said, is all the money that's going to hit my cash register when I sell these 200 items. Well, my marginal revenue is how much money I'm going to make from selling each subsequent item. Now, it may be that I start off selling that first item at a certain price, and then I find that it takes me longer to sell that item than I had expected. So I'm thinking in my head, well, maybe I may price it just a little bit too much. Right? So I reduce my price on the next item or the next item after that, which means my revenue for that next item has fallen. So the marginal revenue is the additional revenue I get from selling each subsequent item. And it may be by the time I get to the 150th, 155, 157 items, the additional revenue I'm getting from each subsequent item is smaller and smaller and smaller until maybe I get to the 178 item. That 178 item, when I sell that, I realize that I only made just enough money from that 178 item to cover the cost of that 178 item. If that's the case, should I try and sell a 179 item? No, because I'm only making just enough when I get to 178 to cover the rest, to cover the cost of the 178 item. So my marginal revenue is the extra money or the extra revenue I'm making when I sell each subsequent item. On the other hand, the marginal profit is the additional profit that I get from selling each additional item. Now that's different from the marginal revenue because my marginal profit also takes into account the cost of producing and selling that item. So it very well be that when I start plugging in the cost of, remember we said, let's say these items require some sort of additional effort once we get them on island. They need to be stored in a certain way, displayed in a certain way, whatever. The point is there's some additional cost now that we weren't factoring in when we were just straight out selling these items. So the profit then takes into account the cost associated with bringing these items in and making them available to sell. So therefore, the marginal profit is the extra profit I'm earning from the production and sale of the next item, of each subsequent item. And that may be different from item to item. And it may be that, when we talk with revenue, I had to get all the way to 178 item. Maybe that 178th item was the one where I didn't make any extra money off the 178 item. On the other hand, for the profit, marginal profit, because I'm including costs, right, I may not make any profit by the time I get to the 155th item, as opposed to 178 item, when I factor in the costs. Right? So what we're saying is that from a business perspective, there are two things I'm very interested in as a business owner. I'm interested in the marginal revenue is that when I get to that very last item, that when I sell that, I make just enough money to cover the cost of that item. And for my profit, the very last item I sell for which I am actually making a profit of that item. Right? So all what we're doing when we're talking about a simple model of the firm is trying to understand from the firm's perspective, how do we get to that point? Because when we get to the point where we that very last item that we're selling, we make just enough money to cover the cost of that item. That means we have made all the money we can possibly make from the sale of those items. That's our maximum revenue or our maximum profits. So we want to keep going and keep selling until we get to that very last item so that we can get every single dollar that we can possibly make out of our efforts to bring in and sell these items. That's what we're trying to do. Now, we said there are a couple of ways you can do that. Right? If you have relatively few items, right, and the items are discrete or whole items, then perhaps you can do it in this form we call enumeration. Right? Yeah. But if you have a case where your items there's a ton of them, and they're available in very fine amounts, in decimals, right? Then this method is very, very tedious and imperfect at best. So what we're looking for is a more improved method that allows us to determine to a very fine degree that very, very, very last item. How do we go about doing that? Well, we fall back on a couple of things that we think we know, right? We know if we had to take, for example, here's our profit curve. If we take our profit function and we plug in various Qs, Q0, Q1, Q2, Q3, etc., we end up in a table like this. If we look at our profit column on the table started with negative 100, 12, 84, etc. If we take those numbers and we plotted them in a graph, the graph is going to look like this curve. It's going to have a parabola shape, an upside down curve. And in fact, any function that has a q squared in it is going to graph as a parabola. If it has a negative, in this case, negative 20q squared, is going to be an upside down parabola. If it's a positive q squared, it's going to be a right side up parabola. But it's going to have that curve shape every time. Now, we can look at this curve shape. So we graph it, and then we look at it and say, you know what? There's clearly a peak to this curve. And if we draw a line from that peak over to the horizontal axis, we can see that is the highest level of profit available looking at this curve. And then we draw a line straight down, and that will be the level of output at which our profit is at its highest point, which our profit is maximized. So the highest point on that curve is associated with our maximum revenue and the level of output at which our revenue is maximized. And that's easy enough for us to look at a curve and see that, in fact, that point is somewhere between 3 and 4. If we go back to our table, we can see when our output is at 3, our profit is 116. And our marginal profit is 32. That means that when we produce and sold one more item, so when we went from producing and selling 2, producing and selling 3, we saw that our profits went up from 84 to 100, sorry, let me start again. When we increased our production, we saw our profit went up by 84, and our extra profit, as a marginal profit, reducing and selling one more, went up by 72. So I said, oh, that's nice. We'll produce and sell one more. So we produce and sell one more, our total profit went up to 116. The extra profit that we made from selling that one item went up by 32. So, oh, okay. So we reduce and sell that one extra item, and our profit went up by additional $32. It made sense to keep the party going, to produce one more. But when we find out that when we reduce from 3 to 4, our profits fell. Right. Now, it's easier for us to think, though, that then maybe 3 is the peak. Maybe 3 is the best that we can do. Except that marginal profit is positive. That marginal profit says that if you were to try and produce and sell more, you would still make more money. So somewhere between 3 and 4 is when your marginal profit is 0. Okay, think about it this way. 2 analogies. Let's see if any of them work. Right. You have a posh party, all right? And for this posh party, you are giving out champagne, right? Now, you know that 2 things you cannot afford to happen. You cannot afford to have all your guests in their black tie and their evening gowns, and you run out of champagne. Right? You can't have people get shared out. Right? But at the same time, champagne ain't cheap. Right? And what doesn't get consumed at this party probably gonna end up sitting in your fridge forever, wasting. Now, 3 cases of champagne ain't enough, because you still have people who ain't got no drinks. 4 cases is too much. You end up with champagne left over. So you know the ideal amount is somewhere between 3 cases and 4 cases. So what is your next step then? Since that we're not dealing with case anymore, you said, okay, well, maybe 3 cases and a bottle, 2 bottles, 3 bottles. And you keep on adding bottles until you get to the point where you have opened enough bottles where all your guests have champagne. In that case, then you don't need to open any more bottles. That's what we're talking about. You're trying to get to that point somewhere between 3 and 4, because at 3, there is still room for improvement. But at 4, you've gone too far. If we go to our graph, if you look at our graph at 3.0, you see we still can go a little bit higher in terms of improving the amount of revenue that we're, the amount of profit that we're collecting if we increase beyond 3.0. Right, we can go up higher on that curve, close to the peak of the curve. But by the time we get to 4, we're already past the peak. So what we're trying to find that Q star, that Q that's exactly associated with the peak. That's what we're trying to find, right? All our efforts involved is trying to find what's that 3 cases plus how many bottles to make sure all our guests are satisfied, but nothing is wasted. That's what we're looking for. How do we go about finding that? We go about finding that by combining a couple of things that we can figure out. Right? So let's start with what we know. Right? If you look at the peak of this curve, right, that is the only point in which, if you draw a flat line and a line that just barely touches any point on the curve, it's only at the very top of the curve is that line flat and horizontal. Any other point on the curve, that line is not going to be flat and horizontal, not and only touch one point on the curve. There's only one point on the curve where that line can touch the very top of the curve. And the only line that can just touch the top of the curve, is a flat horizontal line. A flat horizontal line is a line that doesn't have a slope, or really what we say a slope is equal to 0. That is, it's not leaning one way or leaning the other way. It has no slope, or the slope is equal to 0. Well, okay, that's nice on a graph, but what does that mean for us in the real world? Right. If you take any function, like the ones that we have here, right, the slope of any function is what we call the rate of change. Think about it this much. If you look at our demand function, the first one, the slope is how much quantity is going to change when we change the price. Right? Rate of change, how much sales are going to change when we change the price. Our demand function says that what price that we need to charge when we change quantity. So again, we're talking about the change between the two variables. If you look at our revenue function, we want to know how much revenue is going to change when quantity change. So the slope of the revenue function is how much revenue is going to change when quantity changes. The cost function, how much cost is going to change when quantity changes. And again, the slope of the cost function is how much cost is going to change when quantity changes. The profit function is how much profit is going to change when costs change. So the slope of the profit function is how much cost changes when quantity changes. Now, let's go back to our curve for a moment. Our inherent difficulty in our calculation is if you look at this profit curve, it's not a straight line. It's not smooth. It's not even. So in essence, the slope or the rate of change is different at every point on this profit curve. Or if we bring it down to reality, we're saying the amount of profit that we are going to earn is going to be different depending on how much we produce and sell. The amount of profit is not going to be the same at every level of output. Because it may be that if we sell very little, our profit may be very small. In fact, our profit may be negative. Because if you look at this curve, where we have the negative 100, that's where Q is equal to 0. That says that when we don't produce anything at all, our profit is minus. Our profit is negative 100. And as we produce more, our profit goes up. But at some point, called Q star, is our profit is increasing as much as it can increase. When we start trying to produce more than Q star, our total profit may go up, but the amount of profit we're getting from each item that we're selling is going down. So what we find is that we look at our profit curve, that rate of change, that slope, is changing at every point on this curve. So how much profit we're going to earn is changing depending on how much we're going to produce and sell. We do know, though, that at the very top of that curve is where our slope or our rate of change tells us that this is the most profit we're going to get from this level of output. So the slope at the top of that curve is flat, or a slope equal to 0. The top of that curve says that's a slope equal to 0. And that slope is what we call the rate of change, at how much profit changes when output changes. Now, we have a term that we've learned for when rate of change, when profit changes, when output changes. That's what we call marginal profit. This is what we have here. Marginal profit, that is how much profit changes when output changes. Marginal profit is exactly what we're talking about. All right. So, two things now we have here. We know at the top of this curve, we have a flat line, which represents the slope, and we said a flat line means a slope equal to 0. But at the very top of that curve, we also know that marginal profit is another word for our slope. And if our slope is equal to 0 at that point, it must mean that marginal profit is equal to 0 at that point, which means that we have managed to get every bit of profit out of our activity as we can possibly get. So at the very top of that curve, we know you have a slope equal to 0, and we have a marginal profit which is equal to slope, but therefore at the top of that curve, the marginal profit must be equal to 0. That's all we're saying here. At the top of that curve, we know two things are happening. At the top of that curve, we know there's a slope that's equal to 0. That means there's a flat line. At the top of that curve, we know marginal profit is equal to the slope, and marginal profit therefore must be equal to 0 at the top of that curve. So if we can now fix in our heads then, okay, at the top of that curve, marginal profit must be equal to the slope, and marginal profit must be equal to 0 at the top of that curve. So now, if that's the case, then all we need now is to figure out what is the Q star that's associated with the top of that curve, which means the Q star that's associated with the maximum profit, which is the same Q star that's associated when marginal profit is equal to 0. So at the top of that curve, marginal profit is equal to 0. At the top of that curve, slope is equal to 0. So we need a Q star that satisfies our marginal profit equal to 0. So if we can have a marginal profit equal to 0 equation, and if we can somehow solve such an equation for a Q, we will know the Q that we're looking for. So ultimately, that is what we want. As a business, we want to know what is the level of output at which our profit will be maximized. And our profit will be maximized at a point where our marginal profit is equal to 0. Now, everything after this is how we go about doing that. Right? So what we're interested in is finding, we just said, we have all these functions here. We have all these functions. And we said the slope of these functions is how much one variable changes when the other variable changes. How much revenue changes when output changes. How much cost changes when output changes. How much profit changes when output changes. So the slope of all these functions is the rate of change. So then our interest in the slope then is the rate of change of these functions. What we're calling derivation is finding that slope, finding that rate of change. So it's difficult. So, sorry, it's easy if you look at, say, the cost function, right, to find out what the rate of change is, to find out how much cost is going to increase when output increases. If we're not producing anything, the only cost we have is our fixed cost. In this case, 100. So if our total cost function is C equals 100 plus 38Q, if Q is 0, then our cost is just simply 100. And every time we produce one more unit, our cost goes up by another $38 or whatever it is. Right? So it's easy enough to look at our cost function and see what our slope is going to be, what our rate of change is. But if you look at our profit function or our revenue functions, they are a bit too complicated for us to just look at them and say exactly what they are. So what we need is a methodology to find out what the rate of change, what the slope of those functions are. And that's what derivation is all about. Differentiation is all about. So here's a method, 3 or 4 simple rules to finding the slope of those complicated curves. Right? So these rules will tell us what the slope is at any given point or any level of output for associated with these functions. So let's walk very slowly through the rules. I think I emailed these to you as a separate attachment. So, and I'm going to go back and forth between these and looking at our equations, so we can see, I did something wrong, how they relate. So let's start with the first rule. First rule is called a constant rule. It says, if you have a function with a number in it all by itself, what we call a constant. A number is called a constant because a number cannot change. It's just a dot. So if you have a function with a constant in it, the slope of that function as it relates to that number has to be 0, because remember now, a slope by definition is the rate of change. But since a number cannot change, a number cannot have a rate of change, so the rate of change of any number must be 0. So if we look at our cost function, and we say we're trying to find the slope, if we take this cost function and graph it, we're trying to find the slope of that line. First things first, we have in our cost function, we have 100, a number just sitting out there all by itself. So it says, if we try to find the slope of that cost curve, immediately we eliminate 100 because the slope of So our constant rule says, if you have a function with a number in it all by itself, a number that's not associated with any variable, that means there's no x's or y's or q's before it, no x's or y's or q's or anything else after it. A number sitting out there all by itself. Then the first derivative or the slope of that number is 0. Right? So we have, for example, our C of Q, our cost function, and this cost function doesn't have anything else in it, it's just a 0.5. In that case, the marginal cost is 0. There is no slope. So the first rule of differentiation or derivation is that if you have a function with a number in it all by itself, if you try to find the slope of that function, or the first derivative in mathematical terms of that function, you can immediately eliminate the constant or the number by itself. Do we have any other functions where we have a number all by itself? For the moment, let's ignore the marginal cost and marginal revenue functions, and we'll explain those in a moment. Look at our price function. We have a 170 all by itself. So if we were to graph that line, we end up with a line. We don't know what's the slope of that line or the rate of change of the line. The first thing we do, we eliminate that 170 because it's a number all by itself and a number doesn't have a slope. So we eliminate the number, and then we only have to deal with the negative 20Q. Same with the cost, we only have to deal with the 38Q. So the first rule says that if you have a function with a number in it all by itself, you can effectively eliminate that number when you're trying to find the slope of that function. The second rule, then, which is called the simple product rule, says if you have a function and your function has a number followed by a variable. So the number is not sitting out there by itself anymore, it's associated with a variable. So for example, in this case, 10x, there's an x after the 10, or 0.25q, or 200q. There's a letter or a variable after the number. So in such a case, then we're saying the slope of that function with respect to that little piece there is just the number. So the slope of, if you have a function that's 10x, the slope or first derivative of that function is just 10. If you have a cost function that has 0.25q, the marginal cost or the first derivative of that function, same thing. The marginal cost is the economic term. The first derivative is the mathematical term, but we're still talking about the same thing, is 0.25. If you have a profit function that is just 200q, then the marginal profit or the first derivative of that profit function is just simply 200. So if we go back to our examples, start with our price example. So if we're saying, okay, if we were to draw this line, all right, we plot this price line, 170 minus 20q, and we're trying to find the slope of that line. Rule 1 says we can immediately eliminate the 170 because the slope of a number is 0. And then rule 2 says that if you have a number with a letter behind it, a variable, a number that's associated with a variable, the slope would just be that number. In that case, it would be minus 20. Can't forget the negative sign. So this is saying when we increase our output by 1 unit, we would need to lower our price by $20 to get that unit sold. That's what the negative sign means, the price has to go down. On the other hand, let's look at our cost function. If we were to draw this line, just plot this cost line, and we're trying to find the slope of that curve, we said to find the slope, rule 1 says we can immediately eliminate the 100. So we can immediately eliminate the 100. So rule 1. Rule 2 says that if you have a number with a letter behind it, so a constant associated with variable, the slope is just that number. In that case, this would be positive 38. So this tells us something we already know. This says that if we increase our output by 1 unit, if Q goes up by 1, the extra cost is $38. But we knew this already because we've seen this in our enumeration exercise. That cost goes up by $38 every time we produce and sell 1 more unit. But the first 2 rules, I lost my space. Oh, come on. The first 2 rules allow us to deal with that cost function. The first rule allows us to get rid of the number that's all by itself. And the second rule says that if you have a number with a letter behind it, like 0.25q, then the slope or the marginal cost then would just be 0.25. So if we try to find what's the marginal cost, we know the marginal cost is not, as we have it here, 38q. The marginal cost is 38. Because rule number 1 says that we eliminate 100 because a number, a constant all by itself, doesn't have a slope because it can't change. And rule number 2 says if you have a letter in front of a number in front of a letter, a constant in front of a variable, the slope is just the constant. So The slope of our cost function is what we call marginal cost. The slope of our revenue function will be what we call marginal revenue. The slope of our profit function will be called marginal profit. And why is this looking like this? Okay, no, that's fine. So the first two rules allows us to deal with functions that look like number 2 and number 4. Rule number 3 is what we call a general power rule. So rule number 3 is probably the most complicated of all of them, and it's not all that complicated. Okay. Rule number 3 says, listen, if you have a function in which a variable is raised to some power, q squared, q cubed, q to the 5th, whatever it is, right? If you have a function with a variable that raised to some power, to find the slope of that function as relates to that particular portion, this is how you go about doing it. So let's say, for example, we have a revenue function, and our revenue function has the form 200q squared. So q is raised to some power. The rule says, the general power rule says, in that case, if you want to find the slope of that revenue function, and the slope of the revenue function is what we call the marginal revenue, you take that power and you bring it down. So I brought the 2 down in front of it, and then you subtract 1 from the power. So if we have a function in which a variable is raised to some power, then to find the first derivative or slope of that function, we bring down the power, and by bringing down the power, we copy the value of the power to the front of the equation. That's what we mean when we say we bring down the power. We copy that 2 to the front of the equation. If you look at the next example, we have q raised to the 3rd power. In that case, we brought the 3 to the front of the equation. If it was x raised to the 10th power, we'd bring the 10 to the front of the equation. And then we say we subtract 1 from the value of the original power. So we brought the 2 to the front of the equation, and then we say we subtract 1 from that 2. We brought the 3 to the front of the equation, and we subtract 1 from the 3. If this was q to the 4th, we bring the 4 in front of the equation, and then subtract 1 from the 4. Right? So for our marginal revenue equation, we brought 2 to the front of the equation, and we subtract 1 from the power, 2 minus 1. Right? 2 times the 200, that gives me 400. 2 minus 1 is 1, so that'll be q raised to the 1 power. Well, any number raised to the 1 power is itself. So we end up with 400q. In this next example, we have our profit function is 1000q raised to the 3rd power. So according to our rules, this is what we do. We bring down the power, so we brought it to the front of the equation, and we subtract 1 from it. 3 minus 1, we end up with 2, and 3 times 1,000, we end up with 3,000. So we end up, in that case, a marginal profit slope, first derivative of our profit function, equal to 3,000q squared. Hold on to that thought a second, and let's just touch on that 4th rule before we go back and look at our real-world examples. The 4th rule is just the additive sum rule, and all the additive sum rule says that if you have a function with multiple parts, so if you have a function that can be broken down into 2 or more separate functions, then you just deal with each function, each part separately. So the slope of that whole function is the slope of each one of those individual functions. So if you have, like, for example, look at our cost function that we have here. Our cost function is 100 plus 38q. The additive or sum rule says, okay, we deal with 100 as a separate issue, and you deal with the 38Q as a separate issue? Well, we know, according to rule number 1, lost my place. Rule number 1 says if you have a number all by itself, like this 100, the slope of that number is 0. And rule number 2 says if you have a number in front of a letter, like this 38Q, the slope of that is just the number. So we end up with a marginal cost equal to 38. What about the revenue equation? All right. And this is our actual revenue equation. Our revenue equation was 170Q. Let me make sure I got it right. Here's our revenue equation, 170Q minus 20Q squared. At 170Q minus 20Q squared. Right? Our fourth rule says, okay, if you have a function that you can separate into different parts, then you can deal with each part separately. So we certainly can separate this into 2 parts. So we can deal with a 170Q part, and then we can also deal with a minus 20Q squared part. Right? So to deal with a 170Q part, rule number 2 says if you have a number with a letter behind it, like this 0.25Q or this 200Q, then it says the slope is just that number. So if we go to our revenue equation, and we deal with the 170Q first, then the slope of that with respect to the marginal revenue, or the slope of the revenue equation with respect to the 170Q is just simply 170. So we deal with the 170Q first. Then we said, okay, now let's deal with the 20Q squared part. But because that Q is squared, that looks like the general power rule, or rule number 3. And rule number 3, the general power rule, says, what do you do if you have something that's raised to a power? Right? So you have a variable that's raised to some power. In this case, the Q squared. Rule number 3 says you bring down that power, so you bring that to the front of the equation. That's how I brought the 2 down and put it in brackets. So I brought the 2 to the front of the equation. And I did something wrong here. And it says you subtract 1 from the power, not 2. Oops, I went too far. Okay, here we go. And it says, once I've done that, then you subtract 1 unit from the value of the original power. The original power was 2Q squared. So I subtract 1 from that, we end up with 1, Q to the 1, but anything raised to the power of 1 is itself. So I end up with a marginal revenue, or the first derivative of my revenue function, or the slope of my revenue function. All of this is saying the exact same thing, equal to 170 minus 40Q. So I have a marginal revenue equation of 170 minus 40Q. So what this allows us to do then, it says, we're now able to look at the complicated equations, like our revenue equation and our profit equation, and find out the slope of those curves at any point. Now, that only gets us halfway home. All right. Let's go back to our profit for a moment. Here's our profit curve. All right. And finding out the marginal profit, or the slope, says that, okay, we found out what the equation is to allow us to calculate the slope at different points on this curve, or different level of output. So we can find out, right, what the slope is when producing 3 or 4 or any number. And that's nice, but we want to know the top of this curve. So the marginal profit, and what we just derived, a marginal profit is the slope of the profit curve. Well, what we want to know Because when we were talking about here, we said we want to know at the top of this curve, the marginal profit or the slope is equal to 0. So now that we did all that hard work and we derived what that function should look like, we derived this marginal profit function. Where is it? Oh, I've lost it. There you go. We derived the marginal profit function and the marginal revenue function. What we want to know is, though, at the top of that curve, we know marginal revenue, marginal profit is equal to 0. That's what it is at the top of that curve. So once we've established that we've derived that function, we need to then turn around and set that function equal to 0 to allow us to calculate Q. The best way to do this is to walk our way through an exercise. All right. So let's put the last touches on our notes, and then we go to our class handout and our in-class exercise and work our way through this. So here's our notes. Previously, we developed a typical revenue function. Here's our revenue function, 170Q minus 20Q squared. Using the rules of differentiation, we can do marginal revenue. That's what we just did. We said rule number 2 allows us to deal, rule number 4, remember, says if you can break it up into parts, deal with each part separately. That was rule number 4. All right. So we could break up our revenue function into 2 parts. So now we know we could deal with each part separately. We don't have to worry about that issue. Fine. Rule number 1 says if you have in your function a number sitting out there all by itself and connected to nothing, well, we don't have such a number, so we don't have to deal with that. So rule number 1 doesn't apply to our revenue function trying to find the marginal revenue or the slope of the revenue function, because we don't have any number, any constant sitting out there all by itself. So we don't need no rule number 1. Rule number 2, however, says if you have in your function, you have a letter, a number, and a letter together, 170Q. In that case, then, you can deal with that one piece first by using rule number 2. And rule number 2 says, if you're trying to find the slope of the curve with respect to that one little piece, you just need the number all by itself. So the marginal revenue or the slope of the revenue curve with respect to 170Q is 170. Then rule number 3 says, okay, if you have in your function a variable, a letter that's raised to some power, in that case, we got a Q squared. So yeah, we got that. So it says, okay, if that's the case, how do you deal with that? Rule number 3 says you bring that power down to the front of your equation. So I brought the 2 down. And then the rule also says, well, that's step 1 of it. Step 2 of it says you then subtract 1 from the original power. So I said I had 2 was my original power. I subtract 1 from that, I end up with 1. But anything raised to the power of 1 is itself. So I end up with 2 times 20 is my 40. And so I end up with a marginal revenue equation of 170 minus 40Q. So we said, now that we have obtained our marginal revenue equation, if we want to determine the level of output that would maximize our revenue, we know that revenue is maximized at a point at the top of that curve, and the top of that curve is when marginal revenue is equal to 0. So if we want to find Q star, we have to take that marginal revenue equation, whatever that is, set that equal to 0, and we'll be able to solve for our Q star. So how do we do that? We take our marginal revenue equation, 170 minus 40Q, that's what we got all along. So we use our second, third, and fourth rules of derivation to get our marginal revenue, or to find the slope of our revenue equation, same thing. So the top of the curve is a point where marginal revenue is equal to 0. So here's our marginal revenue function. set it equal to 0, well, we just set it equal to 0. We plug in 0. In that case, then, can we solve for Q? Well, you have negative 40Q on the right-hand side. If we move that to the left, that now becomes positive 40Q. The 170, we didn't do anything with it. If we take the 0 on the other side, it becomes negative 0, if there's such a thing. But that's going to fall away anyway, because whether it's positive 0 or negative 0, it's still 0. So I have 40Q equals 170. And Q, therefore, would be 170 divided by 40, and Q works out to be 4.25. So what we've determined then is that, let's go back to our revenue for a moment. Yes. Revenue, that's the one. No, let's go back to our revenue here. We saw at 4, look at our marginal revenue. Our marginal revenue was positive. That means, according to our marginal principle, as long as marginal revenue exceeds marginal cost, you should increase production. So we should go beyond 4. But if we go to 5, it becomes negative. So 4 isn't far enough, but 5 is too far. So we know then that the peak is somewhere between 4 and 5. Let's see if we can find our graph. That's our wrong graph. Here's our revenue curve. Our peak is somewhere between 4 and 5. We don't know where it is because our current understanding at this stage doesn't allow us to know exactly where. We know it's somewhere between 4 and 5. But when we use our marginal principle, we've derived our marginal revenue, and we set it equal to 0, we find that the actual perfect value is 4.25. We know that because look what happens if we try 4.26. At 4.25, our marginal revenue is still positive. At 4.26, our marginal revenue is negative. Now, of course, we can get even more precise and figure out exactly where it's 0. It might be 4.2, 49 or 599999999, not quite to 4.26. But if we leave it at 2 decimal places at this point, 4.25 units of what we should be producing. Because if we try to go to 4.26, we find that we've gone too far. Our marginal revenues become negative. And the only way to do that is by taking our, deriving our marginal revenue equation and setting it equal to 0 and solving. So using the enumeration process was only able to give us a value of 4 for Q. But using our marginal analysis and the rules of differentiation, we now know that we will need to produce exactly 4.25 units to maximize revenues. So you will know that even at 4.26 units, marginal revenue is now negative. And then we do exactly the same thing for the profits. Previously, we developed a typical profit function. Our profit function is 132Q minus 20Q squared minus 100. And again, rule number 4 says that if you have a function that you can break it up into pieces and deal with each piece separately, then that's what you should do. Fine. So then we look at our profit function, and we see there's a number in there all by itself, a constant. And rule number 1 says, if you have a function with a number in it all by itself, you can, in essence, draw a line through that number and move on. All right? The slope of that number is 0. Rule number 1 says that if I'm looking to derive the marginal profit equation from my profit function, So I'm trying to find the slope of my profit function. It says, okay, I can eliminate the constant, the 100 that's sitting out there all by itself. So I scratch that out and move on. I've dealt with that piece. Now I have the 132Q piece of my function. Well, rule number 2 says that if I have in my function a number and a variable, 132Q, 25X, 15Y, 32K, whatever it is, if I have a number and a variable or a number and a letter, the slope of that function as it relates to that particular piece is just the number. So that 132Q becomes just 132. Always remembering to keep the sign. Then now all we have left to deal with is the negative 20Q squared. And rule number 3 says, if you have in your function a variable, some letter that's raised to a power, how do you deal with that? Rule number 3 says you bring the power down. That is, you put it to the front of the equation, put it in brackets, so you understand, so there's no confusion there. And you subtract 1 from the original power. Our original power was 2, so we subtract 1 from that. 2 minus 1 is 1. Anything raised to the power 1 is itself. So we end up with 2 times 20, that gives me my 40. 40Q raised to the power 1 is just 40Q. And I made sure I kept my sign. So I end up with marginal profit is 132 minus 40Q. That's my marginal profit. Right? So that function tells me what the slope is, or allows me to determine what the slope is at any point on that curve. Well, that's all very nice and good, but I'm not interested in the slope at any point on that curve. I'm interested in the slope at the very peak of that curve, at the very top of that curve. Well, at the very top of that curve, we just said that's a flat line. And a flat line has a slope equal to 0. So if my marginal profit equation is the way I calculate the slope, at the top of that curve is slope equal to 0, then what I need to do is set my marginal profit equation equal to 0 and see if I can use that to solve my Q. Right. So I take my marginal profit equation, 132 minus 40Q, and I set it equal to 0. I said 0 equals 132 minus 40Q. Yada, 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 yada. Move my negative 40Q over, become positive 40Q. My 132 stays where it is. The 0 goes to the other side, but 0 is 0, so that fades away. And I end up with 40Q equals 132. Q, therefore, is 132 divided by 40, and with a Q star of 3.3. And if we go to our table, this is in yellow. I took the liberty of going all the interim steps from 3 to 4 so we can see what happens. At 3, when we're producing 3 units, we remember we said our marginal profit was positive at $32. 3.1 units, our marginal profit is still positive. It's only $1, but it's positive. As long as it's positive, we keep going. 3.2 units, still positive. 0.6, but still positive. 3.3 units is now down to 0.2. That's like 20 cents, but it's still positive. We should keep going. So we go to 3.4, and we go, it went negative. So 3.4 is too far. 3.3 sounds about right. Now, if we want to get down to 0.0, we may need to go to 3.31 and see what happens. 3.32 and see what happens, 3.33 what happens. And we can do that. But at this point, we just want to make sure we understand that this methodology, marginal analysis is what we're calling it, allows us to get much more precise than the enumeration method. So this allows a firm to have a much clearer, much more deeper understanding of how much I need to produce and sell if I'm going to make every single dollar that I can make. All right. I'm not in the business of leaving any money on the table. My job is to maximize my revenue and maximize my profit. And maximizing my revenue only occurs at a point where my marginal revenue is equal to 0. And my maximum profits only occurs when my marginal profit is equal to 0. So that's what I need to find out in any case. Okay. This is just more notes the same. We can send it, this is just step by step of how you go about doing that. All right. So ladies, that is the sum total of the notes for this microeconomics class. What I want to do now today is to walk our way, or let you walk me through the class exercise. And on Tuesday, I will give you your mock final, so you have a feel for how this is going to work. For example, let me see if I can pull it up. You share the in-class exercise that we're looking at now. This will probably constitute the last third of your exam, if not the last 40% of your exam. All right. So this one question is probably going to be worth at least 30, somewhere between 30 and 40% of your final exam. Because I haven't finalized final exam yet, I can't tell you precisely, but I can tell you with a fair degree of certainty, in every exam I've ever given, this one question has never been worth less than 30%. Okay, and you'll get it pretty much almost exactly looking like this in terms of the layout. So, any question before we jump head first into this? All right. So, McNuggets International, you get a word problem like this: hired a consultancy firm to evaluate the efficacy of continuing to serve its fish sandwiches alongside its signature nuggets. That's just words. It doesn't really have anything to do with the question itself. It's just laying out the problem for you. The firm produced the following demand and cost equations for McNuggets fish out of sea sandwiches. Right. It sounds like a real business. We ain't call it McDonald's, it's called McNuggets. So the demand equation for the fish sandwiches is QD equals 385 minus 0.5p, and the cost equation is 1,000 plus 200Q. That's all the information you're given. And you're asked the following, you're tasked with producing the following analysis for the use of the company. So they want to know, produce the inverse demand equation, produce the revenue equation, produce the marginal revenue equation, marginal cost equation, profit equation, marginal profit equation. First things first. Right? Then they ask you, determine the quantity of output that will maximize revenue. And then it says, how much is the revenue that a company is going to make if it were to produce this amount of output? And then they want to know what price they should charge if they wanted to sell this output that which you just figured out. And then you do the same thing for profits. All right. So then, anybody ready to get their hands dirty? You can jump in here at any point in time. But I would suggest that you have your exercise, your thing in front of you, and you can work along with me so that you can refresh your mind when you have to do it on your own. Okay, so how do we get our inverse demand equation? We start with our demand equation. And what we need to do is to invert it, or right now we have the quantity demanded is the dependent variable, it's on the left-hand side, and the price is the independent variable. We need to swap them. Right. So then, anybody want to walk through this easy one, or y'all gonna let me do this all by myself?
That would be 385 divided by 0.5.
Okay, I think you missed a lot of steps in between somewhere.
No, it's P equals 385. Oh,
so first things first, can we put the P on the left-hand side?
Yeah, right.
Okay, so 0.5P equals, and we put the Q on the other side because that's what we want to do, right? We want to swap the P's and the Q's. 385. Now I have a positive, on the left-hand side, that's a positive 1Q. It's just that we don't normally put the 1 in front of a positive number. But once we move it to the other side and it becomes negative, we have to put the 1 in front of it. Right, so we end up at negative 1Q. Right, so right now, we've swapped the P's and the Q's. So far, so good?
yes.
Okay, but now we don't need 0.5P, we need P all by itself. So to do that, we need to divide everything by 0.5. So we enter 0.5P divided by P, which is technically what we're doing, equals, because if we divide 0.5P, by 0.5, the 0.5s will cancel, and that will allow us our P all by itself. All right. But if we did that, the whole point of an equal sign says that things on each side of the equal sign are assumed to be equal to each other. All right. It's an equality. So that means if you make one change on one side, you have to make the same change on the other side to keep that equality. So I needed to get the P by itself. I know if I divide 0.5P by 0.5, the 5s cancel out, and I end up with P all by itself. But if I do that on the left-hand side, I have to also do that on the right-hand side. So that means on the right-hand side, I need to do the 385 divided by 0.5, because that's what I did with the P. But I also need to do the 1 divided by
0.5.
0.5. And whatever the answer is going to end up with Q after it. All right. So 0.5P divided by 0.5 is P. Okay, what's 385 divided by 0.5?
7,700.
Sorry?
7,700.
7700?
Yeah.
That doesn't look right.
Yeah, that's right.
It's not 770?
No.
It's 770.
What did I do wrong? Let me see.
You're
Hold on.
dividing
Oh,
by
I put 0.05. Yeah.
Don't be scaring me. I'm pretty sure with my math. All right, but don't make that mistake though. All right, because you understand that once this inverse demand equation is what you're going to use to get your revenue function, and your revenue function is what you can use to get your profit function. So if you get this wrong, everything else going down the road is going to be wrong. And then you need to hope that, you know, I marked this inverse demand equation wrong, but then I said, okay, but she used the wrong equation, but she did it the right way all the rest of the time. Anyway, okay, let's not do that. And what's 1 divided by 0.5? Come on, you guys, I know that one.
It's 2.
So we end up with an inverse demand equation of 770 minus 2Q. Fine. What about our revenue equation? We just want to remind ourselves that revenue is price times quantity.
So the revenue equation would be, we would put the P equals 70 minus 2Q.
770 minus 2Q. Oops, sorry. Q in brackets.
Times Q.
All right, so wait, hang on, let me put, this should be
Put the
for my
R
revenue.
equals.
Okay, I almost forgot that. All right. That look right?
Yes.
Okay, fine. So then revenue is equal to, now, to clear the brackets, I need to multiply each element by this Q. So I have 770
Q
Q.
minus 2Q squared.
2Q squared. All right, give me a moment, let me fix that. Font, superscript. Okay, that's my revenue. Do I need to do anything else with that?
Nope.
No.
Okay, all right. Now, marginal revenue. Now, to get my marginal revenue, I need to do my 4 rules, right? Because remember, marginal revenue is the slope of the revenue equation. And since I know you all have your rules open up in front of you, let's start with my revenue equation. Let me put that down. Oops, I don't need to put it, I can just copy that from here. Okay. There's no number. Okay. So, marginal revenue. Now, here you have a number in front of a letter. In my head, that says rule number 2. So then, using rule number 2, what do I put down? If I have a number in front of a letter, I'm giving you big hints, it's rule number 2. Let's go back to my notes. New share, here's my notes. Oops.
Mr. Demary, can you send us these notes, please?
Which notes?
The one we used tonight?
The one that we're looking at now?
Yes, your slides.
Okay, I thought okay. I don't know, how far did I send you guys last time?
Let me check and I'll let you know.
Okay, so let's go, rule number 2. Here it is. If you have a function, like our revenue function, with a constant followed by a variable, See, you have 0.25q. Then the slope or the first derivative is just the number. Here again, 200q, the slope or the first derivative is just the number. So then, if we go back to our revenue equation, what would 770q be?
770.
Second rule, if you have a number in front of a letter, that's it. Okay, now you have a letter raised to some power. According to our rule
That
number,
cancels out.
is that rule number 3? Here it is. And if you guys can see that, I'm not sure I was sharing it. Yes. Rule number 3 says if you have a letter raised to some power, you bring the power down, and then you subtract 1 from the original power. All right. So if that's the case, then what do I do here? All right.
Minus 2q.
No, I need to bring the power down first. And that's what they said. I bring the power down. And then here's my original stuff that I had here before. And I subtract 1 from the original power. And let me make that a superscript. Isn't that what they told us to do? You bring down the original power, and then you subtract 1 from it. So let's see, let's go back to our notes, make sure we did it right. All right. Here it is. Rule number 3 says we had something raised to q squared. So bring down the 2. So we put that in front in brackets, and we subtract 1 from the original power. That's what they told us to do. Okay, so let's go back to our exercise. Right, so that looks about right. Okay, so then MR therefore would be equal, here's my 770. I didn't do anything with that.
Minus 4q.
Minus 4q. Because 2 times 2 is 4. 2 minus 1 is 1. But anything raised to the power of 1 is itself. I need that needs to be capitalized. So now we know our marginal revenue. You know what? Let me give that a different color so we can keep track of what we're dealing with. All right. And here's our revenue. Okay, so now if we think we've done it right, we have our inverse demand equation, our revenue equation, and our marginal revenue equation. What about our marginal cost equation? Because our cost equation is equal to 1,000 plus 200q. Our marginal cost, therefore, we already know what this is, right?
The change in cost divided by the change in q.
Yeah, but what's the equation? Because remember, we said what we can do. Okay, tell you what. Let's now that we established how to deal with all these equations, let's follow those rules. That way, we're not picking and choosing which rules we're going to follow. We know that the rules of differentiation, we said we're going to apply them to all of the equations and see what happens. So what do you do finding the slope if you have a function that has a number in it all by itself, a constant? rule number one is that what do you do when you have, if you have a function with a constant, that is a number that's not associated with any other variable. Then we said that fades away, the slope of that is 0. So the marginal cost or the slope of this function as it relates to the 1,000 is 0. Rule number one says if you have a number all by itself, there's nothing else on this number. There's no x's, there's no q's, there's no y's, there's no k's, there's no m's, there's no n's. Excuse me. It's a number all by itself. Remember what we're trying to do. We're trying to find out the slope of this curve. In this case, we're trying to find out how much the cost is going to change when we increase our output by 1 more unit. So then, what about this
0
200
plus
Q?
200 Q.
You sure?
Mhm.
200 Q or just 200? You're thinking about the
200
second rule. The second rule says that if you have, let me go back so we can see it again. Second rule says if you have a function with a constant followed by a variable, 0.25 Q or 200 Q, the slope is just 0.25. The Q falls away. See here again, 200 Q just becomes 200. So in that case, our 200 Q just becomes 200. So we end up with a marginal cost equal to 200. Shall we look at that again?
Yes, please.
I think the notes you sent us before from last week's class, it was wrong there.
You sure? Let's see. So, I think you may be right, because I think I recall making a correction. Here, yes, here.
Yeah.
Oops. What did I do? I did something wrong. I don't think you guys can see my screen anymore, can you? Screen share. Now you should be able to see it. Okay. So here, this should just be, I see, this should be just 38. Okay, so please make that correction. My apologies. Oof. Yeah, that's not good, especially when people are relying on the notes. Okay, so then, let's go back to our exercise. Why am I this thing? Okay, so we have a marginal cost then equal to 200. Because rule number one says if you have a number all by itself, a constant, the slope of that function as relates to that constant is 0. When you have a function with a number in front of a variable, slope is just that number.
And the homework, I wouldn't get that wrong, right?
Oh, you mean if you relied on the notes? Fine, whatever, fine. Fine. All right, profit. What's our profit equation? Insert.
So it'd be profit equals R minus cost.
Revenue minus cost. Okay, fine. So what's our revenue?
770Q minus 2Q squared.
70Q minus 2Q. I'll make the thingy, the subscript. Font, superscript, actually subscript, and minus cost. And what's our cost? 1,000 plus. That look right? Our revenue is 770 minus 4Q. Oh, no. Yes, our revenue is 770Q minus 2Q squared. And our cost, where's my cost function? My cost function is here, 1,000 plus 200Q. So if profit is revenue minus cost, here's my revenue equation, here's my cost equation. So shall I remove my brackets? So profit therefore
You're missing a zero
Why, what zero?
on the 770.
Oh, 770. Yes, okay. All right, so. All right. So to remove the brackets, I have 770 minus 2Q squared. Now, when you have a negative sign between the brackets, it means that everything in the second bracket switches its sign. No, not negative, it switches its sign. Because if this was a negative number in the bracket, that number would have become positive. So we just say, everything switches its sign. So that plus 1,000 becomes, oops, what did I do? Oh, okay. Plus 1,000 becomes negative 1,000, and this plus 200 becomes negative 200Q. All right. So I don't need that bracket. So we end up with 770Q minus 2Q squared minus 1,000 minus 200Q. And then we collect our terms. Let me save myself some typing. Not really the typing part, it's the doing the superscript part that I'm trying to save the effort. Okay. So we end up with 770Q minus 200Q. So we put the Q's together, Q squares together, and numbers together. I've used of that. I don't have any, I only have one Q squared, right? This negative 2 squared, I don't have any other Q squares anywhere. So that stays, and the 1,000 stays. Agreed?
Agree.
Yes.
All right, so let me bold that and put it in red. So that is my profit equation. Now, I need to find marginal profit. All right, so here's my profit equation. Okay, let's paste that, and it's not, no number, no bold, and black. Okay. So now, marginal profit, insert symbol. All right, so now we have three pieces in this equation. We have the 570Q, the minus 2Q squared, and the minus 1,000. Right? But rule number 4 says if you have an equation with a bunch of pieces, you just take each piece separately. Right? Okay, so can we take each piece separately? Let's start with the 570Q. That's a number in front of a letter. That looks like rule number 2. And rule number 2, let's go back to our notes. Rule number 2 says, if you have a function with a number in front of a letter, simple product rule, then the slope of that function with respect to that particular piece is just the number. So 0.25q becomes just 0.25. 200q just becomes 200. So then, using that same logic, what about 570q?
Just
It becomes
570.
570.
Just 570. All right, fine. Now, this negative 2q squared, that is the second rule. No, that's the third rule. All right, let's go back to our notes. Our note says, the third rule, called the general power rule. If you have a variable raised to some power, that's q squared, you bring down the power, you put the power in front of your equation, and you subtract 1 from the original power. So in this case, you bring down the 2, and you subtract 1 from it. Here, you bring down the 3, and you subtract 1 from it. Okay, so let's go back. Oh, for heaven's sakes. Share screen. I didn't realize you guys can only see half of my head. Okay, so then here's our marginal profit. What do I do with this negative 2q squared?
2 times 2
Times
gives
it
you
into
4.
So why don't I, let's see.
-4.
Let's see. Can I bring down the 2? Because that's what they told me.
Mhm.
Right? And subtract
Take
1
away
from
1.
this. Right? And what am I missing?
1,000.
I'm doing, okay. Right, okay. That looks right? Yes, that looks right. All right, so here's the 570 minus 2 times this thing here, minus 1,000. So let's clean that up. Copy and paste. 570 doesn't change. 2 times 2 is 4, so it gives me minus
4q.
4q. 2 minus 1 is 1. Anything raised to the power 1 of itself. So I end up with 570. No, what do we forget?
Take out the q.
Why are we taking out the q?
No, you're leaving the q.
We need the q.
I thought that's what the rules say.
No, the rules say.
No, you leave the q. We subtract the 1 from the 2 so that it remains, it stays the same. So it would be
Right,
4q.
see, yeah. See, we kept the q, rule number
Oh.
3.
Okay.
So, no, that's not the issue. We didn't do anything with the 1,000. See, here's our profit
Are we
equation.
supposed to bring it over?
Yeah. What do the rules say when you have a number all by itself?
Make it 0.
0.
Right, so this.
You'd remove it altogether.
Right, we remove that altogether. Remove that altogether. Oops, no, hang on, sorry. This becomes 0, which in essence means that we can move this all, get that out of the way completely. And that will be our marginal profit equation. And I need that bold, and I need that red. So we have our marginal profit, 570 minus 4q. You begin to see why this is worth 30% of your exam grade. We still got a bunch of questions to deal with. Okay, so then determine the quantity of output that will maximize revenues. How do we do that? Let's go back to our notes.
Use the revenue equation.
Say again?
You would use the revenue equation
Hang on. See, this is
and
why,
just plug in the
we
numbers.
go to the notes. Okay. Previously, we've developed a typical revenue function. And okay, so this is how we got our marginal revenue. Now that we have obtained our marginal revenue, we can now determine the level of output that will maximize our revenues. Is that what we're being asked for? Determine the quantity of output that will maximize revenues. Yes, that's what we're being asked for. So how do they tell us we should do that? Okay, says, now that we have obtained our marginal revenue equation, we can now determine the level of output that will maximize our revenues. We know that maximum revenues are obtained when marginal revenue is equal to 0. So we simply set our marginal revenue equation equal to 0 and solve. Ha ha. So we take our marginal revenue equation, set it to 0 and solve. So let's see. So they said determine the quantity of output that should maximize our revenue. And our note said we need to take our marginal revenue equation, set it equal to 0 and solve. So let's find our marginal revenue equation.
770 minus 4Q.
Okay, so here's marginal revenue equation. Copy that. All right, here's my marginal revenue equation. Paste. All right, so doesn't have a number. And it also doesn't need to be bold. Doesn't need to be black. Okay, my marginal revenue equation. And they said set it equal to 0 and solve. To set it equal to 0, we just call it 0. We said 0 equal 770 minus 4Q. You know what? Let me insert a page break here. Okay. That makes it a little easier, I think. Ooh, I did something crazy. Hang on. Here. Okay. I just wanted to keep everything together. So according to our notes, we set our marginal revenue equation equal to 0 and solve. All right. Once we have it like this, what's the next step?
Solve for Q.
And how do I go about doing that?
It doesn't tell us what Q is.
Yeah, we have to find out what Q is. They said set it equal to 0 and solve.
So we just move around our equation to solve for 0? I mean, solve for Q?
Sounds crazy. Okay.
I ask it.
Oh, only one way to find out. So, okay, let's go back to our notes then. And what did we do in our notes? See, we took the negative 40Q, move it to the other side, and boom, 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 solve for it. Okay. So can we do that?
We could do that.
So it's 4Q, right? So I put a 4Q over here. 4Q equals 770 minus 0, which is, I moved the 0 over, but you know, anything minus 0 is just, right? I could do that, right? Okay. So then Q
is equal
must
to
be 770
divided by 4.
And somebody tell me what that is, please.
192.5.
192, oops. So 192 and a half units, or half cases, or half, whatever it is. Right? So now we know this is our Q star. Okay. Let's bold that, and we want that to be red because all our answers are red. Boom. So now we found out that if we were to produce and sell 192.5 units, we will maximize our revenues. Make sense?
Mm-hmm.
Okay. Question 8 says then, how much money we can actually make if we produce and sell 192.5 units. So what is the maximum revenue that the firm can earn if we were to produce this amount? So how do we find out what our actual revenue will, what our revenue will actually be if we were to produce and sell this amount?
We use the marginal profit equation.
No, we
No?
deal with revenues. We deal with revenues.
Oh, sorry.
Couldn't I just like plug that into my revenue equation?
Mm-hmm.
Because I mean, my revenue equation tells me how much money I would make at various output levels, right? Because my revenue equation says, what's my revenue at various levels of Q? But now I have a Q, so I should be able to just plug that Q into my revenue equation. But I need to find what my revenue equation is. Here's my revenue equation. Copy that. Here's my revenue equation. Let's plug that in. All right, so let's fix that because that's no. There. Okay, so here's my revenue equation. Now, I want to find out what my revenue is going to be when I'm producing 192.5 units. Now, this is not involved in the calculation. This is just telling me what my Q is, the Q that I'm using. Right. So if I was plugging in 10 into this, it'll be R10. If I plug in 20 into this, it will be R20. Right. So typically what you would see in some economic textbooks, you will see this written as RQ. So you would know that you would put the reference amount in that brackets. All right. So then, we're producing 192.5 units. Copy, paste. It'll be 770 times 192.5. So every place I see a Q, I plug in 192.5. And I have 2 times 192.5 squared. So you've noticed that everywhere, let's copy that first. Copy.
Mr. Demerit, I confused on why you put Q on the side of R.
Okay. All we're doing when we do that is says we're trying to remind ourselves what the Q that we're dealing with. What we've done up to this point in this class, we've simply left it as R. Right? But technically speaking, we want to remind ourselves what our output is that we're trying to find the revenue for a certain amount of output. What we normally put in that bracket after R is the amount of Q that we're trying to deal with. But I am more than happy at this late date, last day of actual notes in the class, to leave it off. I leave it off. I will introduce it for the next class if you all want to take my class again. And we'll put it in from the beginning. Okay. Does that help? I'll just leave it off. Okay.
Yeah.
All right. Fine. So let's see. Let's do some work, somebody with a calculator. What's 770 times 192.5?
148,225.
14822.5. Okay, no.
No.
No, not point. 225.
148,225.
This is where y'all need to include the comma. So 148, comma,
225.
225, no, nothing after that?
Nothing after it.
Nothing after decimal.
No.
Okay, fine. Now, here you need to solve the brackets first. And the brackets is 192.5 squared. So you need 192.5 times 192.5.
192.5, which is 37,000.
37, comma. Oops.
056.
Hang on. I do something crazy. 37, comma.
056.
056.
0.25.
0.25. Close brackets. All right, fine. I can trust you. I'm assuming somebody's validated your number, because they would have screamed otherwise. All right. Now, I need, what's 2 times that?
74,112 $112.50.
112.50.
Yes.
Right. So then, now I need 148 minus 74112.5.
74112.5 is the answer.
How do you like that? And since this is revenue, we put our $sign there. And that's our revenue when we're producing 192.5 units. Don't worry, I will send you guys this whole thing when we're done. Okay. How far have we gotten? Question 9. What price should be charged to sell this amount? Any ideas?
Fresh.
There's a reason why we produce all those equations at the very beginning of the question, so we can make use of them.
Use the inverse demand equation.
Bingo. The inverse demand equation is also known as the price equation. Right. So we do the same thing we did here. We take the equation and we plug in that Q that we just found out. Here's our inverse demand equation. Copy. Paste. And let's no, you're not a number. Take that out. Here's our inverse demand equation. All right. Copy it again. Copy. Paste. All right. So then, what do we do?
We take the Q and
I'm assuming all of that was gobbled.
192.50.
We put the 9.2.5 where we saw the Q. That was what you guys were saying?
Yes.
Did I hear some but contradictory? No?
No.
All right, okay, all right, then fine, let me copy that, copy. Paste, all right, so what's 2 times 192.5?
385.
385 even. All right, and let's go with paste. And what's 770 minus 385?
385.
And that's price, so $385. 0.00 because we're dealing with dollars. Right. So, bold, bingo. Right. Now, what does it tell us? When we produce and sell 192.5 units, we will maximize our revenues. And we will be earning $74,112.50. And if we were going to sell that entire 192.5 units, we should charge $385 per unit. I don't know what this is we're selling, but $385 per unit. Or it could be $385 a case. I don't know what it is. Wait a minute, we're talking about sandwiches. So yeah, this is cases of frozen fish fillet or whatever it is. Because I'm assuming the store buys its fish in cases, frozen fish. Okay. So shall we do the last three questions? Come this far? All right. Now, if that's the case, determine the quantity of output that will maximize profits. Well, we know what we did to maximize revenues. What did we do? So we scroll up and see. To maximize revenues, here it is. Determine the quantity that would maximize revenues. We took our marginal revenue equation, set it equal to 0, and solve. So to determine the quantity of output that will maximize profits, what do we do?
Use the marginal profit
We use
equation.
the profit equation.
Marginal profit equation.
Marginal profit equation. You see, let's confirm with our notes. And that was revenue. Here, maximum profit, take a marginal profit, here's the marginal profit equation. Yeah, they set it equal to 0 and they solve. Okay, so let's do that. All right, we've done that already with the revenue, so we should be able to do it with the profit without a problem. Here's my marginal profit equation. Copy that. Right, and let's plug it in here. Paste. Bold. Take it out 0. And there's no number associated. Okay. All right. So that's my marginal profit. And we say we set that equal to 0. So copy, paste, set it equal to 0. I just call it make it 0 and solve. Okay. I'm all ears.
So that would be 4Q.
All right. So I move my 4Q over.
Is equal to 570 minus 0.
Okay. So if you don't mind, I'll just ignore the minus 0.
Hmm.
So wouldn't Q then be equal to
570 divided by 4.
Q star is equal to,
Which equals to 142.50.
142.5.
Mhm.
All right. Any dissenting voices? Everybody happy with that?
That's good.
Yeah.
So let's scroll up a second. We found to maximize our revenues, we needed 192.5 units. But to maximize our profit, 142.5 units. So a lot of it depends. If I'm in the business, I'm much more interested in maximizing my profits as opposed to maximizing my revenues, because my revenue doesn't take into account either the costs involved. Okay, fine. How much profit will we be earning if we would produce and sell 142.5 units. So what's the maximum profit that the firm may earn if it were to produce this amount? What do I do?
If we were to produce this amount.
Okay, that you're mumbling.
No, I'm trying to think.
Right, so let's go back to the notes, see what it says. Okay, so, okay, do our notes tell us? Oh, yes, here you go. We can use this equation to determine the level of profit at which profit is maximized. By inserting this value into the profit equation, we can determine the level of profit we receive if we were to produce this amount. So doesn't that sound like we have to plug that 142.5 into our profit equation?
Mm-hmm.
So let's find our profit equation.
Our profit equation into 1 is 570 cubed.
Here we go.
Oh. No,
Oh, that's not right.
that's not right. It's 570 cubed.
I just was gonna ask if there's a reason why we use the longer.
It's 570 cubed minus
Minus
4
2
cubed?
q squared.
No.
Marginal profit is the 4th cube,
Oh,
but
yeah.
our
Oh,
profit
you're
equation
quite right.
is
You're quite right.
570.
Minus 1,000?
Yes, minus 1,000.
Okay. All right. Let me let me check one quick second. 570 cubed minus 2 q squared minus 1,000. Okay. No, I didn't trust you, but I didn't trust you. Okay. All right, fine. So now wherever we have a Q, we plug in our 142.5, right? So 570, plug in 142.5 minus 2 times 142.5 squared. All right, so all I did is I plugged in 142.5 wherever I saw Q. Because what we're trying to do, we're trying to find how much profit we're going to earn when we produce 142.5 units. So Q has to be 142.5 wherever I see 142.5. So then let's see, let's insert. So profit equals, what's 570 times 142.5? Don't forget the comma.
81,225.
81, comma
25.
25, okay. And 2 times, what's 142.5 times 142.5?
20,306.
306.
0.25.
0.25, close brackets, minus 1000. Okay, home, paste. Okay, so 81,225. What's 2 times 2306.25?
40,612.
612.5
0.5.
minus 1,000. Fine. All right, so copy, paste. I have a negative 40,000 and a negative 1,000. So why don't I have 81,000 minus 41? Because I have to, if I had the 2 negative numbers, the 40,625 and the 1,000, I get 41,625. Would you agree?
Mm,
added the two negative numbers together.
okay, yeah, it works.
So now I'm only
Where
interested
you
now.
at, Mr. Demerit?
See the
It still would give you the same
4612.5? So this is a negative 40,000. And this is a negative 1,000. So this is a negative
Oh, yeah,
41,000.
okay, okay.
All right, so insert symbol. All right. So then 81,225 minus 41,612.5.
39,612.5.
Okay, that's two different numbers.
39,612.5.
612.5. And double check it for, please. Just to make sure we're all happy with the number. Yeah, that looked right, at least in my head. All right, so our profit is 39,000. What was our revenue? Our revenue was 74,000. Okay, well, whatever. Once we show we've done it right, whatever the number comes out to be, that's what it comes out to be. Now, what price are we going to charge if we're going to sell 142.5 units? What do we do? What did we do before? See, here, question 9.
Invert.
We use the inverse demand equation.
Yeah.
Or otherwise known as the price equation. All right. But now, instead of our revenue quantity, this is our profit quantity. All right. Oops, I don't need this. I need, okay, I did something stupid. Okay, fix that. Let's see, I can do that. Take that out of there. Okay. So now, what price we're going to charge would be 770 minus 2 times. How much are we producing for our maximum profit? 142.5. Okay. So price therefore is equal to 770. What's 2 times 1.4, 2.5 is 285. 285. And price therefore is equal to what?
485.
485.00. All right. And there we go. Bold red. Do we have, is that it? Yeah, that's it.
Mr. Demerit, this a lot.
That is 35% of your final exam.
You send us a sheet, right? When it worked out?
As soon as this class is over.
Okay, thank you.
In fact, tell you what, yeah, save that and file. Let's close that. Oops, and let's go back to our notes. And let's see. And I have home, I have new, oops, no. I need microeconomics and what do they call this? Class exercise. Please see attached. Let's go class exercise completed. Let's attach a file. Browse. I know where it is. Micro homework. No, it's not homework. It is in class exercise. And it's 8:30 already? Oh, yes, it is. Okay. Insert, send. All right, ladies, I just emailed it to everybody. So hopefully it pops up into your email account relatively quickly. All right.
You email the
Okay.
notes to right, Mr. Demara, or you will do that later?
I guess I could do that now. Wait, you said you were supposed to check how far I've gotten with the notes. I can check that because the class notes is a very large document. So I don't want to try and send the whole thing if I don't have to. I think I sent you Microeconomics. Oh, I sent this last time. Let's see. This class notes. Let's see where we ended. Okay, I see. Determining maximum profit. Did I send the? Okay.
It ended there.
Okay, so let's see. I don't even know what page that is.
If that's 30% of our final exam, what's the other 70%?
I don't know yet. I can finish writing it at some point between now and, because your exam is next Thursday, right? Just today is what? Today's the 17th. And your exam's on exam's on the 26th. Yeah, we could do your exam on the 26th. All right. I will send you a note reminding you. And we'll talk about it on Tuesday. I will, okay. I have to do some cutting and pasting. Hang on a second. My apologies. Let's see. Let's go from the end of a class to all of those. Right, so let's copy that and let me add it to the existing class notes, the one I just sent you guys. We have a complete set, paste, file, close, save, oops, yes, save. And let's go to, no, not to, all right. Now let's go new, and this is micro and attach micro. Make sure it's the document we're looking for. Oh, but the formatting didn't come through. Okay, that's fine. All right, so I have sent everybody the class notes. All right, I think that's it for the evening. All right, where are we? Sorry, folks, let's bring this up again. Let's see. Everyone got my note from previously, right?
Mm-hmm.
Yes.
No class on Thursday.
All right. Okay. So I'll see you guys on next Tuesday then. All right. Thank you very much, everyone. We have a good evening.
Good evening.
All right. Stop share and let's end class.